Hey everybody, this lesson is going to cover subtracting linear expressions. Now this lesson is a lot different than just adding linear expressions. There's a big difference between adding and subtracting, so that's why these lessons are separate. So make sure you go into this lesson not thinking, you know what, I already did this. I already know what's going on. There is a lot, I should say, that is different from adding that you're going to need to kind of make note of here. So let's go ahead and get started. When subtracting expressions, distribute the negative into the expression that is in front of it. Another way to phrase this whole thing, distributing a negative, is to, you might hear your math teacher say this, add the opposite. So you might hear me refer to it as adding the opposite in a lot of different ways here, which just means it's just another way of saying distribute a negative. Okay, so let's go ahead and take a look at example A here, which is x plus 15, the expression x plus 15, minus, and this is where you have to pause. In algebra a lot, you've got a minus sign here, you definitely have to stop and think. Minus signs definitely have to be thought through. So when you have a negative in front of an expression, whether it's in front of a term, you definitely have to think about those. So we have x plus 15 minus the expression x plus 21. Now notice, the minus is not just in front of x. I know it's closest to x. I know it's really close to that x right there, but it's in front of this entire expression, x plus 21. So what we have to do is we have to distribute this negative in front of x plus 21. You might have some math teachers that refer to this as being another invisible 1. So they might think, oh, there's a negative 1 right there. So you're going to multiply everything by negative 1. Now the thing is when you distribute a negative, is that the same as making something negative? There's a little bit of confusion with that. When you distribute a negative, yeah, if it's positive, if you're making positive 5 negative and you're distributing a negative in front of it, yeah, go ahead. You're going to make 5 negative. But what if it's already negative? What if it's negative 5 and you're distributing a negative? Does that make a negative? Well, no, it makes it the opposite. So minus negative 5, adding the opposite of negative 5, makes positive 5. You don't have to write plus 5 if it's positive, but it's important to note that it made positive 5. It made a positive. So distributing a negative doesn't necessarily make things negative. It makes things the opposite of what they once were. If they were positive, now they're negative. If they were negative, now they're positive. So it's a better way to think of that. So let's go ahead and kind of do this using the vertical method. So I'm going to write 1x plus 15. Then I'm going to distribute negative 1 into the x. So that's going to make negative 1x. And then we're going to distribute negative 1 into 21. That's going to make negative 21. So I'm going to write plus negative 21 there, just to kind of emphasize that 21 is now negative. Now the interesting thing here that you might notice is that right here we've got the x's, 1x, and we've got negative 1x. You might notice those cancel each other out. They make 0x. Right? There's no x. They cancel each other out completely. They've wiped each other out. The constants, however, don't wipe each other out. They don't cancel each other out. 15 plus negative 21 is going to make negative 6. So really, you don't need to write 0x plus negative 6. We can just write our answer is negative 6. That's it. That's all you need to do. I mean, I'm sure it's okay if you want to write 0x plus negative 6. There's nothing wrong with that. But again, it's a little bit unnecessary to have to write 0x, because 0x just means 0 times x. What's 0 times anything? 0. So you don't really need that. You can just put negative 6. That's perfectly acceptable. Okay, again, just kind of like following this pattern here, following this general theme that we're talking about here. We have a negative there. And again, we can just think of that as a negative 1 that's being distributed. So we're going to distribute the negative 1 into x, and we're going to distribute a negative into something that's negative already. So I'm just going to drop down the 6x, and I'm going to write 6x plus negative 15. And then when we distribute the negative into x, that becomes minus 1x. You don't have to write minus 1x if you want to just write negative x, that's fine too. But if you're especially new to this, and this is something that's difficult for you, it doesn't hurt to put that 1 as a coefficient in front of lone variables. And then this 15 was negative before, but distributing a negative made it the opposite. So now it's plus 15. Now in this one, when we look at how things stacked up here vertically, the x's, 6x minus 1x makes 5x. And you'll notice for this particular example, the constants actually cancel each other out. Negative 15 plus 15 are additive inverse, so it really makes plus 0. And again, if you want to write 5x plus 0, that's fine. Go ahead. But you don't really need it. You can just write 5x. That's all we need to do. So 5x is a perfectly acceptable answer. Now this example C right here takes it just a little bit further. You'll notice here that we don't just have a negative in front of the second expression. We have a number here as well. We have negative 4. This is more understandable for some people because there's an actual number there. It's hard to always imagine that there's like the imaginary numbers everywhere. But in this case right here, in this example, we're going to distribute negative 4 into x, and we're going to distribute negative 4 into 17. So I'm going to drop down 10x, and then instead of writing minus 6, I'm going to write plus negative 6. All right, and then we're going to multiply. So negative 4 times x is negative 4x. And then negative 4 times 17 is going to be a negative. So I'm going to write plus negative 68. And now in this example right here, this is our first example where nothing really cancels out. So we've got 10x and we have negative 4x, so I'm going to subtract those and you get 6x. And then we have negative 6 plus, because we're basically putting like terms together here, we have negative 6 plus negative 68, which makes negative 74. And we're all through with that particular example. There's nothing else we can do to it. 6x plus negative 74 are not like terms, and this is simplified down into as few terms as possible. Now, additionally, I want to go over a few application problems using linear expressions. Now, one is going to involve adding, another one, of course, is going to involve subtracting. In this example right here, I'm going to go ahead and just read through this. It says you start a new job. After W weeks, you have 10W plus $120 in your savings account. Now, let me just kind of analyze what that really means right there. 10W. What's that 10W mean? That means 10 weeks. That's what that means. What does 120 mean? Well, it means, I'm sure you know, it probably means 120. But $120, what? That means there was $120 in your account at the start of all this. You know, before even the weeks started adding up, before you started doing anything with your savings, you had $120 already up front to put into your savings account. So you had $120 in there even with 0 weeks. So that's what that means. So in 10 weeks plus $120. So that's kind of what that means. You don't have to do that for every one of these problems, but I think it's important sometimes to analyze what these expressions really mean. Sometimes it gets a little bit abstract dealing with all this algebra. So you have 10W plus $120 in your savings account and 45W, 45 weeks, plus $25 in your checking account. Now write an expression that represents the total in both accounts. Now the key word here is total. Now sometimes that word total can be a little bit misleading, but in this context right here, that means we're going to find the sum, meaning we're going to add those up. So I'm just going to use the vertical method here. We're going to do 10W plus 120, and we're going to do 45W plus 25, and just add those up. So the W's, when you add up the W's, you get 55W. When you add up the constants, 120 plus 25, you get $145, and that's it. So that linear expression right there, if you kind of break it down, that just means you have a combined, 55 weeks. You've been saving for 55 weeks money in your savings account and in your checking account together. And also, you had $145 to start. That's what that all means. So 55 weeks total have passed by in your savings and checking account, and you have $145. Now, that doesn't mean you have $145 in your account. I guess it could if you didn't put anything in your savings account. But in this case, that's it. That's all you have to do. 55W plus 145, and we're finished with this particular example. For this particular example right here, we've got the expression 17n plus 11. Now, that represents the perimeter of that triangle. Now, remember, perimeter is when you add up all the sides of the triangle. You know, when we add up this side, which is 5n plus 6, plus this side, which is 4n plus 5, and then we have this side, which is we don't know. So that's what we're going to have to figure out here. But we know that all three of those sides adds up to a perimeter that is 17n plus 11. This one says write an expression that represents the measure of the third side. So what you're going to do for this one is you're going to want to start with the perimeter, and you're going to want to take away So you're going to want to take the perimeter and you're going to want to take away the sum of the two given sides. And the difference, you know, because that's what subtraction means, the difference should be that third side, which we don't know. So the perimeter is given. The perimeter is 17n plus 11. And then we're going to take that away from the sum of the two given sides. So the sum of the two given sides, well, we have 5n plus 4n. Well, that makes 9n. And then the constants are 6 plus 5, which makes 11. Now, holding true to what this lesson's all about, we're going to subtract the second expression, which means we're going to distribute a negative. Okay, so I'm going to drop down the 17n plus 11. Sorry, that's kind of messy right there. You got 17n plus 11. And then we're going to distribute negative into 9n and 11. So 9n becomes negative 9n. And then plus 11 becomes minus 11. So I'm going to write plus negative 11. If you want to just write minus 11, that's fine. I'm just kind of emphasizing that it's negative. And then if we look at the n terms, now we're ready to put like terms together as much as possible. We have 17n minus 9n, which is going to make 8n. And then you'll notice here the 11s, plus 11, minus 11, those cancel out. So that is your third side right there. So your third side is 8n. Now if you're confused, like, okay, does that all make sense? Well, add them all up. Add up all the n's, all right? We've got 5n, we've got 4n, that makes 9n. 9n plus 8n makes 17n, which is right there. And then 6 plus 5 makes 11. So everything holds true right there. We've got 17n plus 11. Okay, so that does it for this particular lesson. Make sure you do the practice problems that accompany this lesson, and that should do it. Everyone have a great day. See you later.